So, how do we add fractions or subtract fractions when the denominators are different? We have to find a common denominator, okay? If we have an 8 and a 4, what's a common denominator? 8 is a common denominator. Is there any other common denominators? 16 would work, right? 24 would work, 32 would work, all the multiples that both of these numbers divide into. But what we're actually going to look for is not just a common denominator, but the least common denominator, okay? I don't want to confuse you, but like if we used 16 in this problem, we could still get the right answer. It's just if we find the least common denominator, it will be better. Fair enough? Okay, so you told me that the least common denominator is 8. Okay, so I'm going to go ahead and write my pattern down. I'm going to go ahead and write, my fractions down because I want to be able to fill things in as I go. Okay, so I know this has to be an 8 and I know this has to be an 8, correct? What was this one before? Since the denominator didn't change, the numerator also doesn't change. Okay? What was this one before? A 4. Now it's an 8. How did it change? Multiplied by 2. We're not ever going to change a denominator by adding or subtracting anything to it. Okay? It's always going to be multiplication. So, what is 4 times 2? 8. If I multiply the denominator by that number, I also have to multiply the numerator by that number, so my new numerator is 2. Okay? So what is 3/8 plus 2/8? 5/8. So what kind of steps are we going to write down here? Okay, so we want to find... Can I write LCD? Do you know what that means? Can you write it? You'll remember? Good. So somewhere in between finding the least common denominator and adding or subtracting, something has to happen, right? What's happening here? It's the multiplication. How am I going to write that so I remember here? Whatever I do to the denominator, what? I also do to the numerator. Now, I know that makes sense to some of you. Does it make sense to all of you? Okay. Because right here I had to multiply the denominator by 2. So according to this, I also have to multiply the numerator by 2. What happens if I don't? No, the fraction police do not come and get you. Don't worry about that. Okay? But if I don't multiply both numerator and denominator by the same thing, I've changed the value of the fraction, and I don't want to do that. Okay? So look over here at the rational expression. I'm going to give myself a little pattern. Here's a way to think about it. If you're having trouble figuring out the common denominator, think of the factors of these two denominators. Is there a factor that they share? An x. Is there a factor that one of them has that the other one doesn't? A 3. Is there a factor that the other one has that the first one doesn't? No. So guess what the denominator is? The least common denominator. 3x. Okay? Does that make sense? So what did this used to be? It used to be 3x. Now it's a 3x. So the numerator doesn't change. It's still 5. Okay? What did this one used to be? And I need it to be 3x, so I'm going to multiply numerator and denominator by 3. So everything in the denominator, everything in the numerator I multiply by 3, right? 3x plus 3. But now that I have a common denominator, if we have a common denominator, then add the numerators. What do we get? 3x plus 8. Very good. And now I can cancel the 3x's. Gosh, I try to trick you with that every time, and you never do it. You guys aren't any fun. Yeah, I'd prefer you be not fun that way. I'm okay with that. Okay? Sometimes when we're adding or subtracting fractions, in order to be able to find out what the factors of the denominator are, we actually have to factor them. Okay? Can you factor this denominator right here? No, that's as low as it can go, right? Can you factor this denominator? How? If we factor out a 2, what do we have left? X plus 2. Now, something that I've seen is that if you factor out the 2, you're not writing it. It's just like disappearing. That's scary when numbers just disappear. Okay? We don't want numbers to disappear. So even if I just factor out a 2, I still write it. It's still part of that number. Okay? So I'm going to write myself a pattern. Do these denominators share a factor? Or something they have in common already? An x plus 2. Is there something that one of them has that the other one doesn't? A 2? Is there something that the other one has that the first one doesn't? No? So guess what our common denominator is? Very good. 2 times x plus 2. Okay? This one was already 2 times x plus 2, so the numerator doesn't change. It's still x plus 1. This one was x plus 2, and it needs to be 2 times x plus 2. So I multiply numerator and denominator by 2. And I get 18. Very good. So when I do my subtraction, I'm going to get x plus 18, right? Or 19, because I've got 1 and 18. No? Oh, I'm subtracting. X minus, perfect, x minus 17. Okay? Now here's the deal about this, guys. I don't want to go ahead and multiply this back out. Okay? Because of what if we did all of our work correctly and my numerator actually was x plus 2? What could I do? Excuse me. Yes, I could cancel it out, couldn't I? Okay? If I'd already multiplied it back out, I'd have to factor it again just to see if I could cancel anything out. So don't do that. Okay? There'll be a time for that. That time is not now. Okay? So look at example number 4. Problem number 4. Okay? Well, gosh, what would be the least common denominator? 35. Where'd you get 35? So if it's something that doesn't share a common factor, you just multiply them together? Does that work all the time? Yes, it does. Okay? So you're telling me that this should be 35 and this should be 35, right? Draw myself a little, what did I call it a minute ago? Pattern? I don't even know. Okay? So this was 7, now it's 35, so I've got to multiply by 5, so that's 35 and that's 15. This used to be a 5 and now it's a 35, so I've got to multiply by 7, so 14 equals 29 over 35. Excellent. So what kind of steps are we going to write here? Okay, so we're going to write just a slightly different than that, if it's okay. So sometimes to find the LCD, let's just multiply the denominators. And then add or subtract. Does that kind of say everything that you said? Good. I'm not trying to take away the value of your words. You understand? Okay, good. So if in our example we have an x and a 3, do they share any common factors? So what do I do to find my least common denominator? Multiply them together. So what is x times 3? 3x. Here and here. Okay? So this used to be an x, now it's a 3x, so I need to multiply by 3, and I get, very good, 15. This used to be a 3, and now it's a 3x, so I need to multiply by, very good, and I get, wait, 2x squared, are you sure? Good, be sure. Now that I have a common denominator, what do? Just subtract, right? 15 minus 2x squared equals 3x. No idea. Any questions about this? You good? So what about the last one? It looks so ridiculous. Wait, did you just say I look ridiculous? Rude. Okay, so give myself a pattern. Do they share any? Can I factor either one of them first of all? Yeah, I don't want that though, do I? Okay, so I can't factor either one of them. So when they don't share any common factors, let's multiply them. But remember, like we talked about up here, when I say I want to multiply them, that means I want to do this with them. Aren't I multiplying them? But do I want to do all the multiplication and multiply that out? No. Okay? So this used to be x plus 3. Now it's x plus 3 times 2x minus 1. So I have to multiply 2x minus 1 by 4. So I am distributing the 4, correct? 8x minus 4. And then here, used to be 2x minus 1. Now it's x plus 3, 2x minus 1. So I need to multiply by x plus 3. Distribute here. 7x plus 21. Any guesses? Actually, I'd prefer not be a guess, but like a right answer. That's what one person's guess is. I mean, right answer. Does anybody agree with that? Ask her. So the question was, wouldn't it be plus 17? If we have a negative 4 and a positive 21, wouldn't it be plus 17? Very good. Any questions? We good? Okay. Jasa, you going to be brave today? Are you going to be brave today? Come here. There's no oh no's. You can do this. Okay, so look at the directions. Add or subtract each of the rational expressions by finding a common denominator. Hint! 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 I'm sorry I said it 3 times. It only says 1. It may help to factor the denominators first. Okay? So, first of all, we're going to factor the denominators. Can you factor this first denominator? I can't. Okay, she can't. All right. So what about the second denominator? Can she factor the second denominator? Yes. How is she going to factor the second denominator? Do you remember what this is called? The difference of squares. Yeah, that's right. Okay, difference of squares. How do you factor difference of squares? Two parentheses. Write them. Whoa, 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 whoa. Give me. I did, but it's mostly like this. Like that. Not over there. Just under that one. Okay? You just have to write a little small right here. It's okay. It's okay. So, when we factor the difference of squares, we get x plus 2 and x minus 2. Okay? Perfect. Okay? So, give me a pattern. Give me a pattern that we're going to fill in. Put like a line and a plus and a line, like I was doing for you. Okay, but they're going to have to be a lot bigger. That's better. Okay, so look at your denominators. All right, is there a factor that each denominator shares? What is it? X plus 2. Oh. See how they both have an x plus 2? Okay, does that make sense? So you know that's going to have to be part of your denominator. So right to here, underneath, write an x plus 2. Just like as the denominator, right there, x plus 2. Now, is there something that one of these denominators has that the other one doesn't? X minus 2, perfect. Write it also. It has to also be part of the denominator. No, same one. We're just working on the first one right now. And you want to probably put them around those two also. Good. Now, is there any other factor that these two denominators share? Or, I'm sorry, that one has that the other one doesn't have? No. Okay? So that is going to be your common denominator. Okay? So write it in the second fraction. Good. So, that one used to be just x plus 2. Now it is that. What's missing from back here? X minus 2. Perfect. You're so, not confident, but you know what you're doing. I promise you do. Okay? So write it out here. Right beside it, I want you to write an x minus 2. But if you write it in the denominator, perfect. It has to be in the numerator as well. So now what? What do you think? Multiply what? How? Show me. Draw me some arrows. Yes, absolutely. Distribute. Perfect. So now do the multiplication. What's x times 2x? Write it. Perfect. 2x squared. What's 2x times negative 2? Yes, negative 4x. Okay. What is this one now? How is it compared to the other one? These two? They're exactly the same. So what happens to the numerator? It also stays the same. Perfect. Okay. Equals. Give me a one fraction with the denominator that we have. Like line. Yes. Okay. Now let's combine our numerators. Let's add. What do I do with the 2x squared? Is there another x squared term to add it to? Then it goes right to the denominator, or excuse me, right to the numerator over here. 2x squared. What do I do with the negative 4x? Yes, we have to combine our like terms, right? So we have a negative 4x and an x. Write it. Very good. And then what? 11. Negative 11. Perfect. Perfect. Okay. Proud of you. Does anybody have any questions for her? Not for me. She did it. She explained it pretty good, yes? Talked through her steps. Now, do you always get to talk through your steps out loud? But can you? Yes. Pretend like I'm sitting next to you. Well, don't do that because then your parents might send you to a mental hospital or something. Okay? All right, who's doing 6? I want you to do 7. Who's doing 6? Sarah, good job. I'm so proud of you. Yes, you can, math. Okay, ready? Okay, so remember the directions. It might help first to factor the denominators. Okay, so let's start here and factor that denominator. Tell me what two numbers multiply to be 12 and add to be 7. 3 and 4. So how do we write that when we factor it? X plus 3 and x plus 4. Yeah. See, same as her. You know exactly what you're doing. You just question yourself. So now I am your cheerleader. I'm not going to wear one of those outfits, though. Don't worry about it. Okay? Can you factor this one? It doesn't look like it at first, does it? But what do you know? Yes, they're both divisible by 2. Good. Draw me a pattern. Notice how big the denominators are now, so you might want to give yourself some more room. Good. Okay. Now look at the denominators. Is there a factor that they both share? What is it? X plus 4. So you know that's going to have to be part of the denominator, right? Okay. So that takes care of those two, right? Is there something that one has that the other one doesn't? What? X plus 3. Is there something else that one has that the other one doesn't? A 2. So both of those are also going to have to be part of it. So you might want to write the x plus 3 right there, and probably want to write the 2 out in front, just so it doesn't get lost. Yes. So you'll need that over here on this one as well. You guys out there okay so far? How are y'all feeling out there? Woo woo. I'm going to make it rain. It's okay. I'm really not. You don't have to worry about that. Okay, so when we're looking at this denominator, what is missing from the original one that this one has now? A 2. So we're going to multiply it out in front. And perfect. So what do you end up with? Yes. Very good. And then what? What do you want to do now? Very good. Multiply the x plus 3. And you're doing it times the denominator and the numerator. Now, I have to tell you guys, at this point, last period, I had a really good question. Okay? They said, can't we cancel out the x plus 3s? Well, can you? Yes, because we have one numerator and one denominator. But if I do that, I don't have a common denominator anymore, do I? Okay? So we're putting those x plus 3s on purpose so that we keep a common denominator so that we can subtract our fractions. Okay? So go ahead and multiply that out. And now let's do the subtraction. Good. Equals. That's good. So draw yourself a fraction. Good. Why would it be a negative 3? 2x minus 5x? Very good. Close. So close. Just cross out the 1. Very good. Okay. 12 minus 15 is just negative 3, right? Are we good? Can I cross out these 3's? Or, better yet, that says x minus 3, right? So can I cross out the x minus 3 and the x plus 3? Because that doesn't really say x minus 3 at all, does it? Thank you. Very, very good. I have to point out one thing here. Some of you notice that, oh my goodness, we could factor out a negative 3 from both of these, can't I? And get x plus 1. Would there ever be a time that that would be important to do? Maybe. What if there was an x plus 1 in the denominator? Or what if there was a negative 3 in the denominator? Could I cancel stuff out then? Could I simplify it to 1 then? Absolutely. Okay? Now, we can't do that in this particular case, so this is actually as far as you need to go. Okay? We good? Okay. If you don't mind, I'll just do it because we're getting close to the end. I don't want you to miss out on anything, okay? I know you can do it. I promise I do. You already done? Good. Okay. So, I'm going to factor this first. What are my factors? X plus 2 and x plus 4. Very good. What about this one? Right? X minus 3 and x plus 2. So I go to my pattern. Is there a factor that they share? X plus 2. Is there a factor that one has that the other one doesn't? X plus 4. Is there another factor that one of them has that the other one doesn't? X minus 3. Okay? So what is this? Here, let me write it over here. Sorry. So what's the first fraction missing in its denominator? X minus 3, right? So if I multiply the numerator by x minus 3, oh, please remember to do this, right? Please remember to distribute. Right? And some of you can tell already that this is what? 0, right? A negative 3x plus 3x, that's 0. What is the second one missing? X plus 4. X plus 4. So, 9x plus 36, right? Now I have a common denominator, which is x plus 2, x plus 4, and x minus 3. And in my numerator, what do I get? X squared. There's not another x squared to combine anything with, so I just get x squared. I already know that's 0, and I just have 9x. And then I have a negative 9 plus 36. Plus 27. Can I factor that at all? Can you think of two numbers that multiply to be 27 and add to be 9? I can't. So that's just done right there. Okay? Any questions, guys? Your homework is this page right here. Evens. Only the evens. No, babe, that's 2, 4, 6, 8. Okay, just the evens. 2, 4, 6, and 8. Not these over here. Although, can you do these over here for extra credit, okay? This is your last grade of this 6 weeks. Okay?